So as you watch this video, it's going to be a lot more productive if you have your table of your standard reduction potentials. So I've given that to you. You want to go ahead and get that table and have it with you when you watch this video, or the math is going to be a little weird because you won't see where I'm getting numbers from. So we're going to talk about standard voltages. Okay, the standard means the same thing as it did last chapter. If all the ions and molecules that we talk about, if they're in solution, they have to be 1 molar. Okay, so anything that's aqueous, which is going to be quite a bit of this, like most of it, okay, 1 molar. And all gases, so anytime we have a gas, it has to be 1 atm. And again, later on we'll figure out how we can look at the voltages when we're not at standard conditions. The symbol for this is going to be E0, okay? E for electron potential, which is another word for voltage, but we're just going to call it voltage. And basically, this is a measure of how spontaneous a reaction is going to be. Okay, so we did the descriptive stuff last video, and now we're going to see, look at some numbers. Okay, so how spontaneous a reaction is, and by definition how spontaneous it is tells us how much work, how much electrical work it can do for us. Okay, you've heard of voltages, like a 9-volt battery. Okay, remember, batteries are just a bunch of voltaic cells, so we're going to figure out where that voltage comes from. The units of voltage are volts. Very clever. Volts, named after some dude named Volta. So capital V is your symbol. Okay, and every half reaction, okay, if you're going to look at your table now, every half reaction has a voltage associated with it. Okay, and your table is written as standard reduction potentials. Okay, it could just as easily have been written as standard oxidation potentials. Okay, the one you have, are, if you look at them, every single half reaction is written as a reduction. Okay, here's a picture of a table similar to what you have, just smaller. Okay, so it starts, so all of these are written as reductions, and over here you'll find a voltage. So when lithium ion goes to lithium metal, the voltage is negative 3.04. The more negative it is, the more non-spontaneous it is. Okay, so for lithium ion to go to lithium metal doesn't happen very often. Okay, the more positive it is, the more spontaneous it is. And we'll talk more about this table in a bit, but right now we're just kind of looking at numbers. And then you'll notice in the middle of your table, this half reaction, all of them are relative to hydrogen ion plus 2 electrons gives you hydrogen gas. That has 0 volts. Okay, so what we'll do is let me show you how easy them. Say we want to find the voltage of this reaction. So what we do is we write the 2 half reactions. Zinc goes to zinc ion and 2 electrons. And then you go find the table, and in the table you find this half reaction. Okay, zinc, but you'll find it written backwards, right? Because they're all written as reductions. So find the half reaction that says zinc ion plus 2 electrons gives you zinc, and you'll see that the voltage for that is negative 0.762. Since we've written the reaction backwards, we change the sign. So it's 0.762 volts as written. The other half reaction, copper ion plus 2 electrons goes to copper. Again, you go ahead and you find this half reaction in the table. It's a reduction, so you should see it exactly like this. Copper 2 plus 2 electrons gives you copper. And if you look in the table, you should find 0.339 volts. Well, these two reactions add up to give me the overall reaction, so we just go ahead and add up the voltages. 1.101 volts. Okay, well, what does that tell us? the most important thing it tells us is if it's positive, it means it's spontaneous. Okay, so just like when delta G was negative was spontaneous, when E0 is positive, it's spontaneous. So it tells us this reaction would occur. If I put zinc into copper 2+ solution, this reaction would happen. So let's try chlorine plus 2 bromides gives me bromine plus 2 chlorides. Again, let's go ahead and write the half reactions. Chlorine, right, plus 2 electrons gives me 2 chlorides. All right, and if you go ahead and into your table and you find that reaction, that's a reduction. So you should see it written exactly like that. And you should see 1.360 volts. Okay, and then 2 Br minus gives me Br2 plus 2 electrons. Now you're going to find that reaction, but it's going to be written backwards because this is an oxidation, but it's going to be written as a reduction. You'll find Br2 plus 2 electrons gives you 2 Br minus. And when you find that, it'll say plus 1.077. But because we've reversed the reaction, we have to make it negative 1.077 volts. Okay. Again, if we add these up, they give us the overall reaction, right? So I just go ahead and add the voltages. And in this case, kind of subtracting them, you get 0.283 volts. Okay, since it's positive, this reaction is spontaneous. Okay, so chlorine plus bromide gives you bromine plus chloride. That reaction will occur. The reverse reaction would not occur. Okay, we'll do one little piece to it that's important. So 2 silver ions plus 2 electrons gives you 2 silvers. And when you look up the voltage, again, that's a reduction, so you should see it exactly as it appears, and it will say 0.799 volts. Now you're all thinking, oh, but I have to double it. No, 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 no. Even though you think you should, don't multiply by 2, okay? It actually doesn't work that way. All right, it's one of the few times that you're not going to. So even though we doubled the equation from the one you found in your table, do not double the voltage. Okay, so that would be a really good thing to remember. Cadmium goes to cadmium 2+ plus 2 electrons. Again, you should find that in the table, but it'll be written backwards from the way we have it. And I think it's going to be negative 0.402, so we'll write positive 0.402. And again, we can go ahead and add these up to get what we want. So we add the voltages, and we get 1.201 volts. Again, it's positive, so it's spontaneous. So doing the math in these is really simple. Just remember, if it's positive, it's spontaneous. If it's negative, it's non-spontaneous.